Hey there, I'm going to show you the discriminant and what you can determine from a discriminant. You're going to use a discriminant most likely with parabolas and quadratic functions. Now the discriminant is actually found as part of the quadratic formula. It's the part that is under the square root, so it's simply b squared minus 4ac. That's the formula for the discriminant. And you can tell different things based on the value of the discriminant. For example, if the discriminant is greater than 0, then it's positive, and that means that there are two real roots. Now, graphically, this means that you've got a parabola that intersects the x-axis at 2 points. If the discriminant is actually equal to 0, then that means that the parabola is going to intersect the x-axis at just 1 point. You probably have a double root in this particular case. The other possibility is that the discriminant could be negative. It could be less than 0. And if this happens, then you're in imaginary land, meaning that you don't have any real roots. The parabola is kind of floating above or below the x-axis, and it doesn't touch the x-axis at all. So those are the things that you can pick up from looking at the discriminant. All right, enjoy the video, and I'll see you after it's over. All right, in this problem we're going to figure out the discriminant for a specific quadratic function, and that would be this function right here. And I'd like to talk to you first about why we even bother with the discriminant, because that might be helpful for you to know in the future. So you may know that there is this thing called the quadratic formula. And if you don't know the quadratic formula by heart, you're going to need that, so please memorize it. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a. That's the quadratic formula. And it works for quadratics that are in the form of y equals a x squared plus bx plus c. So this is what I would call the general form of a quadratic. And once you have a quadratic in this form, you can figure out what the coefficients are, or the values of a, b, and c, and then you can substitute that into the quadratic formula, and this tells you the roots, basically the places where the parabola would cross the x-axis. Now we're talking about the discriminant, so let's get back to that conversation. What does the discriminant tell you, and why bother learning about it? Well, the discriminant is this piece that is underneath the radical. And the discriminant can tell you a few things. It tells you specific information about the types of roots. So you have b squared minus 4ac. If that happens to be greater than 0, which means that it's positive, you're going to get two real roots. They'll be basically real numbers. All right, so two real roots. If the discriminant is equal to 0, then you're going to get one real root, and it's probably going to be a double root because it'll be the same point. If you have the discriminant less than 0, that means that it's negative. You're going to have imaginary roots, which means you'll have imaginary numbers. Now, just to give you a little bit of extra information here, I'll just show you some quick sketches of what the graphs for these might look like. So if you had two real roots, a quick graph of two real roots would be something like this, because you would have 2 points that cross the x-axis. If you had one real root, basically the parabola would come down and it would touch the x-axis at a single point. If you had imaginary roots, the graph of the parabola won't even touch the x-axis. It will be hanging either above or below the x-axis, but no point of the parabola will actually touch the x-axis. So with that information in mind, we now know the purpose of the discriminant, and we're ready to figure out what's going on for this particular equation. So let's rewrite the original problem, which is y equals negative 2x squared minus x minus 3. And I can tell, based on the values of the general form, that my value of a is negative 2, my value of b is negative 1, and my value of c is negative 3. So to figure this out, I would say that you have negative 1, or b squared, minus 4 times negative 2, because that's our value of a, and negative 3, which is our value of c. So if I figure this out, I can determine what kind of roots I have for this equation. So negative 1 squared is positive 1, and I'm going to multiply these two together. Negative 2 times negative 3 gives me positive 6. And from here, I can multiply negative 4 times 6, which is 24, or negative 24 in this case. From here, I can solve the final answer, which is negative 3, which means that I am going to get imaginary roots. So I am going to be dealing with a parabola where I don't know where it exists, I don't know what quadrant it is, but it's going to have some kind of appearance like this, or it could have an appearance like this. I'm not really sure which one it's going to be, but I can tell you that if I have imaginary roots, no part of this parabola will actually cross the x-axis. All right, well, that's all I have for you on the discriminant. Watch another video if you need more practice. Okay, you just got finished watching a video on the discriminant. So just keep in mind that if the discriminant is greater than 0, that means that you have two real roots, and that this graph is going to intersect the x-axis at 2 points. If you have two roots, the parabola is going to intersect the x-axis at 2 points. Now, if the discriminant is equal to 0, that means that you have just one root. And so that's where the vertex is actually going to touch the x-axis. Now, if the discriminant ends up being less than 0, that means that the discriminant is negative. So if you're going to take the square root of a negative number, that ends up being imaginary. So if the value of the discriminant is less than 0, then you've got imaginary roots. And graphically speaking, the parabola is either going to float above the x-axis, or it's going to be located entirely below the x-axis. All right, so those are my pointers for this video. Watch it again if you need to, and I'll see you next time.